without further ado, let's hang on a second. Somebody's recording me. Okay, here's the terrain, and I'm sure that most of you have been to Globe. One of the interesting things about Globe, and probably an item that a lot of people don't know, is that it was originally a silver district. And the name Globe comes from a 9-inch diameter solid ball of silver that was called a globe of silver, and then thus Globe was named. So this is our project area, and you see the two red hills in sort of the middle ground back there, and that's exactly where we found the big nugget, as well as a number of small ones too. So the first discovery, and I've put this up. This is a lithograph from 1872, I think. So it's about 140, 150 years old. And you see two very anxious-looking people there. This is a prospector in Colorado. But actually, the discovery of the globe silver was just the opposite. The Apaches originally had found detrital silver, and they were smelting it to use as bullets. So the original silver bullet actually has its origin in globe, in truth. And so we have to reverse the picture there. The prospectors actually found the silver by probably trading with the Apaches and finding that the Apaches had silver bullets. So it was originally discovered by the Apaches, and who were, there was no reservation back then. So they roamed all through Arizona and New Mexico. The miners, the early prospectors, followed up with that silver discovery of the Apaches by finding lode deposits in the Richmond Basin. And Richmond Basin, so the prospectors went in there. They went in and mined the alluvial silver, which was in Nugget Wash, aptly named. They followed those silver nuggets back up to the lode deposits, which were in the Richmond Basin, a little bit higher up on the hill. And probably a half a dozen high-grade veins were then mined. This was in the 1870s, early 1890s, up to the 1890s. And during that whole period, the camps were attacked by the Apaches. So it put a certain amount of pressure on anybody that was exploring out there. And then copper started to dominate the region. So Globe was founded with the silver, but then the copper took over, and the copper dominated all the activity out there. So Globe itself was a safe place. But anything outside of Globe in the 1870s, 1880s was subject to Apache attack. So that, coupled with the decline in the silver price, so for a brief period, the United States was on a silver standard. The chaos that ensued and the exit of gold from the United States caused the government to go back on the gold standard, and the price of silver dropped. So the government at some point in the 1880s was buying 3 million ounces of silver a year from producers, which artificially inflated the silver price. Once that was removed, silver declined, and all these isolated silver deposits, no matter what the grade was, they fell into disuse. So the original discovery of this was not through any greater scientific pursuits, but this is the original founder. It's Sam Zamora. He's works at one of the mines up in Globe, and he was a weekend recreational metal detectorist, and he had two companions that went out with him. And instead of watching football one Sunday, they decided to go out and do some metal detecting. Now, I will say that Sam detected for 7 years in the greater Globe area. And in those 7 years, he found 3 grams of gold in those 7 years. Yet he continued. And eventually, this weekend, they found a 16-pound silver nugget. And this is the nugget. We call it the sweet potato. It looks like a number of other things too, but we call it the sweet potato. And that's 16 pounds. And if you notice, it's pretty well rounded. This comes from actually another area, not our area. And it was another 2 years before Sam and his partners found more silver. So they had this initial discovery. They didn't find any more in that area. And then it took them another 2 years to really find the arroyo that these are coming out of. So eventually, Sam and his partners found something in the order of about 200 pounds of native silver in probably 24 pieces. And the sizes that they found ranged from a few grams to up to 120 pounds. So the sample on the left with the hand on it, that's the 120 pounds. It doesn't take a lot of silver to make up weight. And the one next to it is about 80 pounds. So these are the two of the three largest ones. And then the one on the right is probably about 3 or 4 pounds. And these the middle one, the 80 pounder and the 2 or 3 pounder, they have been treated with hydrofluoric acid because generally the silver is encased in quartz. So the one on the left has not been treated. So we made a deal with Sam and his partners. They weren't interested in lode mining. They were, they had jobs. They weren't so much interested in taking any further. So we made a deal with them. And once the deal was done, and they do have a percentage interest in the project. Once the deal was done, we went out and staked lode and placer claims over the area. And I brought in professional metal detectorists from northern Mexico. And in northern Mexico is a phenomenal district with native gold deposits and native gold and placer workings. And so I brought in the professional detectorists down there, and they proceeded to sweep the same area as Sam and his partners had gone over. And we probably found another 100 pounds of silver in the same area. And they had higher power detectors. And a lot of the silver was found at about a 3 foot or 4 foot depth. And with gold, of course, you need a big piece to get down to 4 feet. Usually these detectors only go down a few inches, but depending on the size of the metal, these will go down about 4 feet. So the soil profile isn't that deep out in this particular area. So in many cases, we went down to sort of the rubble interface just above bedrock and found these pieces. So another 100 pounds was found during the first 2 weeks that we swept this area with the metal detectors. So this is one of my associates here, and he's trying to get to the bottom of that hole. It's very convenient to have a small child if you have one. They go right down to the bottom. Anyway, these are some of the samples that we found within the first couple of days, and they've got the weights next to them in metric, so they're in grams. So we've got probably 2-3 kilograms in there, down to a few grams. And then we had a big hit. This is the 417 pounder. And this was just a few centimeters below the surface. So I would say not more than 5 or 6 centimeters. And so quickly dug it out. And we're over probably over 3/4 of a mile from a road, the nearest forest road. And so it was a long haul to get this out. It doesn't look very big. And this particular piece is in the museum right now, downtown Tucson. Doesn't look big, but it is heavy. There was no way to get an ATV or a motorized vehicle in there. So what we did is wrapped it up in corrugated metal sheet. And there were 5 of us, and we drug it out by hand, which is actually no mean feat for the distance that we pulled it. And 5 people really wasn't adequate to haul this over hill and dale. And so the picture on the right here is we had a little bit of a cliff to go over, not a big one, in the arroyo, and to get the piece over this probably 4-foot drop, and you could toss it over the edge, but these things are brittle, and it's mixed with quartz, and so it was our understanding at that time, and still, that we've got the biggest piece of native silver in the world surviving. There were bigger pieces, but they've been broken up and smelted. So this is the largest piece of native silver in the world that we're aware of. We didn't want to make it the second largest piece. So we hauled it over this drop on a metal ladder. And we eventually got it back to the road and threw it on the back of the pickup truck here. And that piece, just the metal content, the silver content in it, and it's not 100% silver. It's about 70%, and the rest is quartz, but still pretty dense. And so here was the weigh-in. We didn't have an idea of how much it weighed, but got it back to Tucson, and to really move it around, 2-3 people can't even move this. So we went down and got an engine lifter and hoisted it up and put it on a scale. And so here we've got the 417. We sent it off to Denver, Colorado, to Brian Lee's, and he cleaned it up. So when we had the silver boulder originally, so it was covered with dirt, we cleaned it off, and but it still wasn't showing much of the metal. And so Brian Lees, who's a famous mineral dealer, took it and soaked it in hydrofluoric acid, so it cleaned up some of the quartz. So it's now 411 pounds. So he dissolved about 5 pounds, 6 pounds of quartz off it in this tank. And he had a forklift to move this stuff around, but it looks a little bit better once it's been hydrofluoric. But you can see a little bit of the texture of the native silver in there. And here it is now as it sits in the museum. So we've got the 417 pounder in the middle, the 80 pounder on the left, and the 120 pounder on the right. And those were the 3 biggest pieces. And they were all found within a few meters of each other. So the 2 smaller ones were down a little bit lower on this arroyo, and the big one was probably, I would say, 15, 16 feet away from that. All found, probably broken off the same vein, the same ore chute. And we walked up the arroyo a little bit more, and there's a vein there. Now, the vein doesn't have any native silver in it, but it's anomalous in silver. It's mainly quartz and siderite breccia. The vein is probably about 1 meter wide, and that's really our focus as an exploration company. The native silver on the surface is like a tremendous soil anomaly, probably the largest silver anomaly in the world. But we treated it just as a soil anomaly. We're really after the mother lode. Where did these things come from? And really, it's let me go back to there for a minute. It's our belief that these haven't traveled very far. We've plotted up all the locations of the detrital silver that we found in the arroyo, and they get smaller. So we had the 417 very close to the vein outcrop itself, and then we had the 80 pounder and the 120 pounder just down the arroyo from that. And as we go down Arroyo, they're probably about 300 meters from the original vein, the fragments get smaller and smaller. So they're breaking up as flood events float these cobbles downstream. And at the end of it, we're looking at say 30-gram pieces. And originally we thought, we've probably got a large silver resource just in the gravels down below. And it's actually hasn't been found to be the case because silver, unlike gold, dissolves. And the only way you're going to find silver boulders like this is to beat Mother Nature to it because they eventually dissolve. In the larger piece here, you see a black coating. That's chlorargyrite. And so the silver starts to oxidize. I'll go into the mineralogy in a second here, but the surface of it is covered with silver tarnish. So the silver starts to oxidize, and then the chlorargyrite is water soluble, so it washes away. These silver boulders, is it unique? No, it's not. They're rare, and they are a rare phenomena, but they're not so unique. So the largest nugget was found at the Smuggler Mine in Colorado, and I believe the one on the left is the Smuggler Mine nugget, and that was over a ton. And it's been broken up, and there might be some existing pieces in a museum, but there's no remnant as large as 400 pounds right now. The other piece was from a mine in British Columbia. It did have native silver in it, but it was mixed with galena, and that's what I think we're seeing in that big piece. Other deposits that have native silver, probably the most famous one is Cobalt, Ontario, which was discovered at the turn of the last century, the 1900s. And they've come to call these 5-element veins because not only do they have silver, but they have nickel, cobalt, arsenic, and that's what we have in cobalt. Now, cobalt it's been mined out. But it was a big district. It was about a 400 million ounce silver district, as well as whatever other metals were pulled out of it. Now there's a lot of interest because there is cobalt there, cobaltite, and so for the battery industry, of course, they're back in the cobalt district looking for cobalt as opposed to silver. But it has a very similar dendritic pattern as ours does up in Globe. And by the way, the host rock for cobalt in Ontario is a Proterozoic diabase intruding Archean or Proterozoic metasedimentary units. And that's exactly what we've got in Globe. So we've got a 1.1 billion year old diabase sill. It's intruding the Apache group, the Proterozoic metasedimentary rocks of Arizona. And so there is that similarity there. So the Globe silver is represented at the Smithsonian Museum. They have a 30-pounder in the Mineral Museum in Washington, D.C., and this is it. And they say silver after chlorargyrite. It should be chlorargyrite after silver. But this was one of the original silver boulders that was found probably in the 1890s or so, and then donated to the museum. But I can tell you that the University of Arizona Museum has the king. They have the big one. Other deposits of native silver, well, the Keweenaw Peninsula in Michigan, a lot of times the native copper in northern Michigan is also associated with the silver. The silver, I think, composes about 5% of the deposit. So, and there are pieces of native silver that can be found detritively in northern Michigan, and also as crystals that are etched out of the wall rock there. Another native silver deposit that occurs in the Southwest is over in Silver City, New Mexico, and that's the Alhambra mine. And the two samples on the right are slabs from the Alhambra mine, very similar setting. It doesn't have the diabase, but it is in Proterozoic granite. And it was mined back in the 1940s. It also had uranium in it. Our textures are a little bit different. They're a little coarser and they're infilled with quartz. So this is sort of what it looks like. And this is the lower left is the assay button from some of the silver that we had assayed. I think it came back about 50% when we sampled this. And we haven't taken a lot of samples. What I do is do a specific gravity test on this because it's a native metal, generally silver and quartz. There are some silver sulfides in there, but generally it's silver and quartz. And so we just put it into a specific gravity formula, and we determine the percentage silver in the rock. But keep in mind that the richest silver deposits right now are probably 1,000 to 1,500 grams per ton. If we converted the percents to grams per ton, we'd be looking at between 500,000 grams to 700,000 grams of silver per ton. So 1 ton of ore, if we can find the source of this, would be worth about $250,000. These are some of the nuggets that have come out. Now, some of them are big and covered with the silver tarnished chlorargyrite. Some of them are that have been tumbled, and the smaller nuggets usually come out with this kind of brain-like texture on the left. And subsequent to our discovery, there have been other metal detectorists, local guys, that have gone out there, not on our property, but on neighboring properties that are under claim. And they've detected 4 native silver, and they have found the native silver without the quartz, and it's beautiful herringbone crystals within smaller specimens. We did do a little petrology here, and we found that the native silver is actually mixed with mercury. So we've got about 2% mercury in the native silver itself. We have just a little bit of silver sulfide mineralization there, and that's in the form of acanthite. We also have very unusual silver minerals, halapite and mckinstryite, which are silver copper sulfides. And one really unusual thing that we found is tin in this. So we've had up to 6% tin in the silver as well. We haven't detected any unique tin minerals in it. We think it's like the silver. It's some sort of an amalgam that the silver is mixed with. But we have a potassic rich intrusion nearby, and we believe that the tin could be derived from that potassic intrusion. While we're waiting for our permits to drill out there, and we have a number of drill holes that we're trying to permit right now to get to the big silver. We've detected about 12,000 ounces of the silver rock, and not only in this particular area, in this particular arroyo, we sent the detectorists out over cross country on our claims, and we found another swarm of silver nuggets. And we believe those are actually overlying another silver vein. And so that's part of our exploration in the district. But in the meantime, while we're waiting for those permits, we had cut some of the samples and they looked very attractive. And so we had some local lapidary guys cut this into jewelry, and that's what it looks like. So it's a really good example of what the textures are like there. And some of the local artists in town here actually made some of our silver into jewelry. So the one on the left is actually just a piece of raw silver that Kevin Smith, one of the local artists, had just ground and polished. And it's interesting because it comes out with a very unique texture here. You can see on the right side of that first photo that there's more massive silver. And then we've got a quartz vein, and you can actually see the quartz crystal outline in that vein. And then kind of disseminated native silver off to the side there. And to tell you the truth, these veins are probably not going to be very thick. They might be 6 inches to a foot wide. The big slab of silver, the 417, is about 6 inches thick. And it doesn't seem, like a very big target. But when you consider it's 70% silver, you don't really need a very thick silver vein like that to make a lot of ounces. And so the other two pieces were done by other artists down in Bisbee, did a really phenomenal job. Beautiful textures in there. You can see some of the herringbone crystalline silver that's been infilled with quartz afterwards. And there's some more. Makes great jewelry. And haven't sold any of it, but we've got 12,000 ounces, and rather than send it to a smelter, we'll probably just deal it off as for material for people to make jewelry out of. Our target is really 100 million ounces. So the ounces that we found are interesting, they're beautiful, but really our target is still in the ground. So our next step in this whole business is to permit. We've staked 100 claims out there, and we'd like to drill this. We've got really good targets. We've had some geophysics and some geochemistry. And by the way, when we wash the dirt off of the nuggets, we assayed some of the just the dirt that sticks to it, and the assays came back 2% silver in just the soil that's around it. So you can see that these nuggets are actually dissolving and seeping into the soil around it. Anyway, we've outlined a few anomalies out there. We're gonna drill test it, as well as the outcrop that these things have probably come off of. I'm just going to talk a little bit about the geology. I think this is an unfolding story, so I don't want to go too much into things that probably will change when we drill. But this is a map from the 1950s. The brown is the diabase. The red is the alkali intrusion, the high potassium intrusion, where we think that tin might have been derived from in the silver. The origin of the silver itself, we don't know. There, at the base of the Apache group, there is a conglomerate that's impregnated with hematite, specular hematite. The matrix of the conglomerate's a basal conglomerate for the metasedimentary unit. It's sitting on top of the Proterozoic granite. And in many places, it's completely permeated with specular hematite. It's black. The matrix is black. And we're just wondering, what could be the source of the silver here? And by the way, the silver, the alluvial silver comes out of the green dot there. So it's in the diabase, but it's not too far away from the potassic intrusion. So what the original source of the silver was unknown. Could it be sort of derived from the sedimentary units quite possible. It had to be in an environment where there are very low sulfur content. For this to precipitate as native silver, in my opinion, it's almost like an electrolytic formation. And there have been recent papers written on these 5-element metal veins. And one theory is that methane was the causative feature in these deposits. That's what precipitated a lot of this sort of hydrofracking by methane gas, and sort of a rapid degassing of the methane precipitated some of the silver. I don't know, but it's seems to me like a very electrolytic process. You know, you get crystals of copper in tank houses. Well, we've got maybe a similar process here in nature. I'll just give you I think this is the final shot, but sort of a regional overview of it. And this is very speculative, but we have sort of an alineation of copper deposits. My personal opinion is that the silver is Proterozoic in age. It's probably the same age as the host rocks, like Cobalt, Ontario, also Proterozoic, like Alhambra over in New Mexico, also in Proterozoic rocks, without any causative intrusion around it. But saying that, there is a lineation of major copper deposits in the area. So we have the Magma Mine, the associated source of that, the Resolution deposit, Carlotta, Pinto Valley, Inspiration, Copper Cities, and they do form a sort of an elongated zone. And if we put our property there, which is it's basically titled the Mexican Mine, which is another native silver deposit up there, and our claim block is in red, it tends to line up very well with the copper deposits. And on our property, we have found veinlets in the diabase that have epidote and chalcopyrite, and that's the shot on the right. We've got a sort of a classic propylitic type vein with chalcopyrite in it that is not far from the silver vein and where we found the silver. But again, the vein that we believe is the source vein for the silver is not propylitically altered. It has no alteration in the rock around it. So could we be looking at two events overlapping spatially, but not temporally? I don't know. And hopefully that's one of the things we'll try to resolve as we go forward with the drilling of this. And you know, I hope I can come back in a few months and say we've really hit the silver, the source of the silver down below here. But just no telling what we're going to find. So it's an unfolding story. And I think that's about it. If you've got any questions that I can entertain, I'll be happy to.
Hello, everybody. If you want to unmute yourself and ask Chris a question, please go ahead.
Hi, Chris. This is Dan Aiken. Thank you very much. That was really interesting. I was wondering, and maybe you covered this and I missed it, but have you done geochems on a broad expanse of the diabase to find out if the diabase might be acted as a heat pump? I know there's uranium associated with diabase up in the Saranches. Is there anomalous silver in any of the diabase? And could that be that interpretation be extended to other diabase locations in central Arizona?
That's a good question, and we've done geochemistry through XRF, and only in the immediate area of the vein. So I can't really speak on the diabase as a whole. But what I will say is this: that over at the Alhambra mine in New Mexico, it was really examined by the USGS as a source of uranium, and there is uraninite in the silver veins over there. The uranium that here on our property, really, I haven't noticed anything anomalous. But I will also say that there are other types of silver veins out here So there's silver veins mixed with manganese oxides and barite to the south of this native silver vein. So I think it's still early days, and I think maybe the diabase being the source or the heat pump is certainly makes sense.
Thank you.
Sure.
This is David Briggs. I've got some questions. You find arsenic or nickel or cobalt associated with any of this, or
no. The arsenic is elevated, but not. There's no arsenic minerals. It seems to be elevated. We've got maybe 1,000 ppm arsenic in this. We've actually done some sampling of water in the area. The water seems to be elevated in arsenic. You know, the nearest well to this is probably about a kilometer away, and I wouldn't drink the water out of the well. I can tell you that. And Allison actually did a study for us out there on the water. But the only elevated geochem we have in this is tin. Mercury, very, very high in mercury. So we had 20,000 ppm mercury in a lot of the samples of the native silver. This is not something you want to cook off in your kitchen. Like the original metal detectorists, they found this, and I think they cooked it off in their house, but that means that there's 2% mercury in their living room kitchen area. So what we also found anomalous is tungsten. We had up to several thousand ppm tungsten in some of the silver, and that's about it. It lacks the cobalt, it lacks the nickel that Cobalt Ontario has.
Have you been able to develop a model? It's probably way too soon, where some of the suspected veins align with extensional structures that might have fed the diabase, and if that's the case, what is it about the Proterozoic uniquely that might have high silver? Was that a particular unique moment in time?
Good question. You know, certainly in Arizona, New Mexico, and Cobalt, Ontario, there seems to be that association with the Proterozoic. Whether the silver came out of the metasedimentary rocks, I don't know. But I will say that I think it's the scanlan conglomerate with all that specular hematite in its black.
Right.
Could that have been the transport mechanism? Could there have been a paleo aquifer along that conglomerate that in some way focused these silver-rich minerals in there? You know, the conglomerate also seems to be a little bit anomalous in silver. Not as high as the native silver. There's no native silver in the conglomerate, but up at the Richmond Basin mines, they actually did mine that conglomerate as a manto because there was a little bit of silver in it, where the silver vein crossed the conglomerate. It blossomed out into a manto, and that was mined, and that's in a thesis dating from the 1930s at the U of A. Could there be some relation? Could have been a source? The conglomerate could have been a transport source. I don't know, but good to speculate on.
Chris, when do you hope to get your drilling program going?
Well, we've been in permitting for a year, and it is on the Tonto National Forest, and I will say that the Forest Service has been pretty amenable. No problems there. The problem they have is that there's no geologist for the forest, and there was a national directive this summer that all able-bodied personnel have to go on fire duty, and so they basically drafted the geologist that was responsible for this area, and he spent 4 months or 5 months up in Montana, fighting fire, and so that puts an automatic 5-month hold on all permitting processes, and they don't have geologists to put into the forest. So if anybody's out there and they want a job, And I've talked to the district ranger. They are looking for geologists to help out with the permitting. And another item that Adam Bromley, the district ranger, mentioned is that the Tonto National Forest is the busiest forest in the country nationally with respect to mineral projects. And he said that they had 28 different applications out just for the Tonto National Forest, which is the highest in the country. And they just can't get professional, experienced geologists to work on the forest.
Yeah. That's fascinating. I had no idea that the Tonto was seen as a real, as a large mineral resource.
#1 in the country, according to the ranger.
Wow, great.
Yeah,
Do you have any more questions?
Yes. How does the deposits in around the Mexican Mine Canyon and Richmond Basin compare to, say, the Stonewall Jackson Mine or Rambo's vein or Rescue vein, both of which were pretty high silver content also?
How do they relate to one another?
Excuse me?
Well, I think they are all related. So I think there's these silver veins that outcropped that they found, and there's probably a large amount that they haven't found. And that's what we're looking at. And, you know, in the cobalt district, there were dozens, literally dozens of small veins. Now, they're not big veins, but they're extraordinarily high grade. And in looking at deposits and how you look at these things, the grade is really the king. And as I said, if you know, we had an ore chute, and these are probably an ore chutes, no doubt about it. But if we had one that was, say, 50 feet long, 200 feet deep, 6 inches wide, we'd be looking at 60 to 70% silver. These are richer than the cobalt veins. If we had those type of grades over that small interval, that would be 50 million ounces right there. So we're not only looking for where this silver came from, we're going to be looking for other veins that are under alluvial cover. They're not going to be big, very short strike length, but they're going to be incredibly rich.
Does it have, what type of lead content does the stuff at Mexican Mine have?
Lead content?
Yeah.
Actually, very low lead. Our silver has very low lead in it.
Very low lead.
Yeah, it's hardly anomalous.
Rambo's camp were saying 50 or 60% lead.
That's right, and I will tell you, Rambos is to the south of us.
Yeah.
And I think what we're seeing is several different types of silver veins. So there are silver veins with manganese associated with it, with vanadium, and actually moly. And so you've got vanidates to the south of us, as well as wolfenite crystals. They're famous collector localities out there. And I think they're probably different type of silver vein that might be associated with porphyry coppers to the south of us also.
That's my opinion, that they are probably related to the porphyry systems as opposed to stuff that, say, Mexican Mine or Richmond Basin or perhaps Stonewall Jackson Mine. I don't know too much about the geology of that one.
I would agree with you. I think there's different type of silver deposits out there.
Okay, and it's just a coincidence information that the porphyries came in and overprinted the older silver.
It's quite possible. Quite possible. Yeah, it might have been a silver-rich environment, and maybe the silver was remobilized out of the older rocks and into these veins around the porphyries.
Yeah, no, the silver district, while it initially attracted the attention of prospectors early on, it just, I mean, they kind of ran out of gas pretty quick, and they switched to the copper as as an alternative, I guess.
Well, you know, when you pick up all the silver on the ground and there's no more silver to pick up, you'll lose interest in it. And with the advent of these metal detectors, the metal detector, I have to tell you, is probably the best geophysical tool we could use out there. And we found another area, not too far, probably 3 kilometers away from this, another area completely completely undiscovered previously. And we probably harvested about 100 nuggets off the top of it. It's actually a cloud. It's a cloud of silver, and that cloud has a strike to it. And we don't see any bedrock. And I assumed, well, these are alluvial outflows from the Richmond Basin. But in actual fact, the silver is restricted to a strike line, probably 300 feet long and 50 feet on either side. And there's just silver nuggets on both sides of it. So what's underneath that? We don't know. But it seems to be localized right there.
What's the trend that you have, Chris, on that cloud?
The trend of the cloud is the same trend as the silver vein we've got to the south, and that's about north 10 east.
Hey, Chris, you have a question in the chat from Gary asking about the origin of the term ruins granite and what is the chemical makeup?
There's probably other people that can answer that better than I. Right here. Please chip in. I don't know what the origin of the ruined granite is, the name of it. But it's also called the Oracle granite. It's a Proterozoic granite that underlies most of Arizona and northern Mexico.
Wow. Well, Chris, this has been great. Maybe we've taken up enough of your time. I should point out that Dave Briggs is too humble to say it, but he's working on a mining history and a geologic history of the globe area that's, I think, has gone now over 200 pages in length, and he hopes to be publishing that soon.
Well, just David, hang on until we make another discovery here. Wouldn't want to exclude the best part of the globe district.
I was gonna say, it seems like you need to add a chapter in there for your work, Chris.
Yeah, just keep the last part, the last chapter open for the finale here.
I'll do that.
Okay, anytime you want to take a look at this, David, be happy to show you the pieces, and let's go down to the museum and I'll show you the big pieces down there. I think you should at least have a photograph of the big pieces for the cover of the book.
We should probably wrap it up. I don't know what time it is. I've lost track. 7:28. Any final questions before we let Chris go? Well, thank you all for us. Thanks, Chris, and thank you all for joining us. And Chris, that was a great talk. So
it was my pleasure. Thank you very much.
Yeah. Thanks, Chris.
Okay, cheers.
Excellent talk.
Cheers. Thank you.
Dave, I'm glad to see you feeling better.
Oh yeah, I'm still hanging in there.
That's good. Corey gave me updates, so I was glad to hear you were doing better.
Yeah.
Yep.
All right. Bye, everybody. Thank you.
Good night, everyone.
Good night.